Hello boys and girls, welcome to the Math Club. In this video, we're going to talk about mutually exclusive events and what does it mean in probability. Now, two events are mutually exclusive if they cannot happen at the same time. For example, when you roll an ordinary dice, you cannot get a 3 and an even number at the same time. And because they're not happening at the same time, we call them mutually exclusive. They don't happen together. Now, I will show you two questions or three questions, and I will show you the difference between them, between having the event as a mutually exclusive events and non or not mutually exclusive events. And I will show you how to answer these questions. Let's check the first question. Question 6. Reasoning. An ordinary six-sided dice is rolled once. The Venn diagram shows two events, square numbers and multiples of 3. So as you can see here, we have two events, square numbers and multiples of 3. And Venn diagram here shows these two events and what happened in these two events with a six-sided dice. Now, as you can see in Venn's diagram, square numbers, we have this and this. And what's the meaning of square numbers? It means that they are numbers or they are the product of multiplying the same number by itself. For example, 1 times 1 will give you 1. 2 times 2 will give you 4. So square numbers are numbers or they are products of multiplying a number by itself. That's why we call them square numbers. Now, the other one is multiples of 3. With multiples of 3, what do we have? We have 3 and 6 in the dice. These are multiples of 3, or the only multiples of 3 that we have in the dice. Now, in the middle, we don't have something in common between square numbers and multiples of 3. This means that these two events here, they don't happen together at the same time. That's why they're called mutually exclusive, because they don't happen together at the same time and they don't share a number between them. Now, let's talk about these two numbers. Why are they outside of the circles? Very good, because they aren't square numbers or nor multiples of 3. So we can't put them in any circles. That's why they're outside. Now, the first question here says, explain why the two events are mutually exclusive. As we said, they are mutually exclusive because they don't happen together. They don't share any numbers here. That means they don't happen together at the same time. This is for A. They don't happen together. Question B, why are 2 and 5 outside the circles? As you can see here, we just explained this. 2 and 5 are outside of the circle because they're not square numbers nor multiples of 3. And this is the answer of B. Question C, what is the probability of rolling a square number here? Now let's talk about the probability of rolling a square number. Now, how many square numbers do you see in a dice? Very good, we have 1, 2, so there are 2 square numbers. So with this probability, we're going to write it like this as a fraction. We're going to write 2 on top because we have 2 square numbers. And then in the bottom here, we're going to write how many numbers are there in the six-sided dice. So how many are there in the six-sided dice? Very good. There are 6. So we write 6 here. Good job. So the probability of rolling a square number is 2 out of 6. Very good. Now, what's the probability of rolling a multiple of 3, which is question D? Same thing here, multiple of 3, the probability for rolling that. How many do we have in a dice? Very good, we have 1, 2. So we make a fraction, we put 2 on top. And then we have 6 numbers in a dice, so we put 6 here. So the probability of rolling multiple of 3 from a six-sided dice is 2 out of 6. Very good. So basically, rolling a square number and rolling a multiple of 3 from a six-sided dice, they have the same probability, which is 2 out of 6. Now, next question says, what is the probability of rolling a square number or a multiple of 3 together? Not at the same time, he means adding the probabilities together. That's why we say or here, because they don't happen at the same time, but you're supposed to add the probabilities. So having a square number is 2, right? We have 2 square numbers, and we have 2 multiples of 3. So the probability of rolling them, the square numbers or multiples of 3, is what? Very good. It's 4 out of 6. We write it here. 4 out of 6. This is the probability of rolling square number or multiples of 3. Now, as you can see here, when we add the 2 exclusive events together, which is the square numbers and multiples of 3, we will get, when you add them together, you will get the same probability of counting them without adding. What does that mean? It means that mutually exclusive events you can add the probability of them to get the probability of the same things. This is the idea of adding the probability of mutually exclusive events. Now, last question here, F, says true or false. Probability of rolling a square number or multiple of 3, which is this one, equals probability of rolling a square number, which is this one, plus probability of rolling a multiple of 3, which is this one. Now, what do you think? Is it correct? Very good, it is. When we add this and this, we will get this. So the sentence is correct. Now, when we explain it, we will say that because they don't share a number and they are mutually exclusive, then we can add their probabilities. This is the idea of this question. And this is how you answer a question like this. Thank you very much for watching. See you next time.